One common applications for capacitive sensors is the liquid level sensor. And you have two different versions here, one for conductive liquids and one for non-conductive liquids. If you have a non-conductive liquid, the capacitor is basically made from this area and this area. So this is the capacitor itself. Of course, the first area here is actually a tube surrounding a center core. So this tube here will make one area of the capacitor, while the center core makes the other area of the capacitor. Well, but let's go back to this basic idea here, that this is the capacitor, and the liquid level will actually, the liquid inside will actually push a dielectric between the two areas. So what you manipulate here is that C equals epsilon naught epsilon R times A over D. You manipulate this one. The non-conductive material between the areas becomes larger or smaller. Remember, over here on top of the liquid you still have a capacitor, but you have a capacitor below it as well, and one portion of the overall capacitance is based on the non-conductive material, which is the liquid, while the other one has vacuum inside it, or air. Actually, air and vacuum basically the same. So the capacitance will change depending on the liquid level. For conductive materials, that means that you have materials that can carry a current. For example, salt water. Salt water is a quite good electric conductor, while, for example, oil is a non-conductive liquid. Actually, oil is sometimes used as an insulator in, for example, transformers. So oil is an insulator, salt water is a conductor. If you have a conductive material, that means that if you use this as one terminal in your capacitor and this as the other terminal, and you put your source between the two, actually the salt water will make this area here shift all the way over here. So you can actually say that one area is the salt water pushing against the rod. So in order to make a capacitor, you actually need to isolate your center rod here with an insulator. For example, cover it in plastic. Now the gap between the two will now be formed by so the capacitor will be the center core, the plastic cover of the center core, and then the salt water pressing on one side. So this area comes from the salt water. It doesn't have to be salt water, of course, it can be any conductive liquid, but this will be on the other side the rod, the center rod. And here you have the coating of the rod itself. Now, this is only valid for the portion of the rod that is dipped in liquid. Above the liquid you have a non-conductive material, which is air. So there you have the very, very large gap, in basically a non-existing capacitor there. So you only basically have an existing capacitor in the range that I point out now. C equals epsilon naught epsilon R A over D. What we manipulate is the A. what portion of the tank forms a good capacitor? That depends on what portion of the rod is soaked in liquid.